Hello all, good morning, good afternoon, and good evening, everybody. So we had two more sessions already completed on how to webinar series. The first one we discussed about the discovery. What are the possible way that we can discover and inventorize to have a complete visibility of your certificates? And the second session we talked about automation, how we can enable automation and help rotate the certificate and manage the life cycle of the certificate and all of that. And the third session, today's session is scheduled to look into more into PKA governance and the control, how we can leverage our CLM tool to enforce your PKA policies and standards and all your enterprise level landscapes, not just one place. So we need to see into all the possible way where we can enforce your PKA policies. All right, I'm Kingsley. I've been working with AppViewX for almost 5 years now. And with the PK field, I've been around 17 years as of now. And working as a principal architect for AppViewX, just a small introduction. And these are all the topics that we're going to cover today. The first topic, what is the need for a PKA control? Why do we need to have a controlled PKA system? In the second topic, we'll discuss about what is certificate policy and what is certificate practice statement and what's the difference between these two. And the third one, we'll discuss about the resource segregation, meaning how we can segregate your certificates and how we can apply a role separation to perform a certain level of task like low-level user or admin level user and all of that. The fourth one will discuss about how we can enforce your defined set of PK policies to your CLM, certificate lifecycle management on a day-to-day, right? And the final topic we'll see about how we can move forward to the crypto agile PK system, not just the certificate alone. How we can move our PK system to a more crypto agile to adapt to any new changes that is enforced by Google or enforced by Nest or Cap Forum and all of that. So these are all three how-to sessions we discussed about, and we are in the third session now. We'll look into the PK governance and how we can streamline our self-service capabilities. All right. So before we start discussing about PK policies and standards, any organization or any government or anything that you wanted to bring control, these are all the four pillars. It's a foundational pillars that you need. One, the people with the conscious mind who wanted to do the right thing in a right way will join together and define a policy, rules, and standards and all of that, right? Say, for example, if you take a government, you need to define a constitutional law that is defined. That is the ground law that is started from the beginning. And if you wanted to make any changes to the constitutional law, you cannot just like that change that, right? You need to have a certain authority. You need to have a proper, permission level and privilege to make any changes and amendments with all the approvals in place, right? So you need to have a people with a conscious mind to define a policy or standards. And the second thing, they need to define the rules and regulations to be documented to define and create a policies. That is where you need to create a policy documents. And the third one, how we can implement this policy to make the people to adopt on a daily basis, right? So these are all the four pillars that you need to have in order to define a ground level PK policies. It not just apply to the government, it applies same to how when you create a policy. So let's talk about what are the policy document that you need to have in order to have a PK governance. So the PK governance starts from PK governance is the core security of a PK system. where you need to start with a certificate policy document, where the certificate policy document is the one which defines the ground rules, meaning how many issuing CAs you need to have, how you need to secure your, root CA, how you need to develop and deploy, what is the deployment model that you have defined, and who has the authority to make the policy changes, who has the authority to make the amendments on the policies. And if you have any OID that you wanted to have a dedicated OID for your organization, then you might need to register one with IANA, and you will have to define the OID in your PKA system so that you can have a reference for your enrollment of all the certificates and all of that. So all that you will be defined only in this certificate policy document. And then follows by policy certificate practice statement, where the practice statement will define how to enroll a certificate, what are the regulations that you need to follow when you do an enrollment. For example, when you enroll a certificate, you should not allow user to enroll SHA-1 certificates, right? You need to define a rule that any certificate, it should be RSA 2048 or higher than that, or SHA 256 or higher than that. So that is how you are going to define the policies. And when you create a root CA, what is the validity period that you need to define? What is the signing algorithm that you need to define for your root CA? And what is the validity period between your root and issuing CA? Obviously, your issuing CA should be half of its life cycle of your root, and your end entity certificate, it should not exceed your issuing CA validity period, right? Let's say if you have 2 years of validity of your issuing CA, and only 2 years is left over, and you're trying to issue a 2 years of certificate, it is contradict the validity period, right? So you need to define those rules in the certificate policy, and then in the certificate practice statement, you will define how to enroll, how to revoke a certificate, and if you want to do a key recovery, how to recover a key if there is a SMIME certificate is issued, and if the SMIME certificate got corrupted, how to recover the key and all of that, right? And then how to enforce the policy. You might be using multiple different CAs, maybe two different external CA or three different external CA. You might have different variety of issuing CA. And how do we enforce one single policy to multiple different issuing CAs? That's where you need to have a CLM tool will act as a registration authority. So that will be CA agnostic. So it can connect with all your issuing CA, either it's internal or external. It can connect with all your issuing CA and enforce all your policy through a CLM. So CP document is this statement description was that I have taken it from the NIST. So it is purely internal document. It should not be published to the external body, and it should be governed by InfoSec team and the PKA team joined together will build this document. And if there is any amendment, they are the one who will be able to make the amendment. So define a policy rules, who can govern the policy, who is authorized to make this amendment. All this will be documented in this certificate policy document. Only those authorized people will be able to make the amendments, and the process and standard on how to follow the PKI standards, right? And with respect to practice, you will find how to enroll, renew, revoke, TLS, client cert, Kerberos, code signing, smart card logon, IPsec, VPN cert, and all of that. And private key access, how to access, what is the level of access you need to give, how to restrict the private key access, how to apply a rule for your wildcard, who can enroll a wildcard certificate, in what scenario you are not allowed to enroll a wildcard cert. If it is a wildcard cert is allowed, what are the approval process, how many layers of approval that you're going to define, and all this will be documented in the certificate practice statement, right? And if you have a practice statement already in place, well and good. If you don't have one, you can refer this RFC document, and this will give you a complete picture of how to create your certificate policy and practice statement documents. All right, let's come to resource segregation. So think of a scenario where an account or a customer doesn't have a CLM tool. They never used a CLM tool. They were using only Microsoft CA as an internal CA and an external CA as any one of the external CA, maybe DigiCert or Interest or any of the external CA they want. So if they are using two different CAs, they need to have two different environment to maintain and manage, and they will have to apply all the policy standards. Even though if you have your CP and CPS, you might have to enforce the policy. Overall, the enterprise level, you will have to maintain and manage in two different places, right? And you will have to provide direct access to your end users to log into the portal, to submit a request or enroll a request or to download a certificate and all of that. You might be able to have a role separation defined within your PKI system. You might have a CA admin who will be allowed to perform only certificate related operations. The CA related operations, who can renew a CA key, or they can make modification to the templates and all of that. And the cert administrator, who have access only to submit a request or revoke a request and all of that. And the PKI system admin, who is not allowed to perform any changes in the CA, but he is allowed to validate the operating system level patches, which is applicable for your PKI system, to make sure that the new OS patch is not impacting your issuing CA. So these are all the roles that you might have defined. But when you look at the account which has CLM in place, where you have more controlled manner, where you can enforce your policy. When you look at AppViewX CLM as a tool to operate your CLM operations on a daily basis, the user is not allowed to access the portal directly. So they will be logged into AppViewX using a single sign-on or through an LDAP as an authentication method, and an authorization will be handled within AppViewX with two different controls. One is roles, other one is resource. So the role is the one which takes care of defining what type of action the user can perform, whether the user is allowed to download a private key, or the user is allowed to access which user group, or meaning which certificate group, whether they are, if the NetOff team, they are allowed to access only certain set of certificates. So that will fall into the resource. So resource is an object, certificate is an object, or a device that you wanted to provision a certificate in F5 or an IAS, it's an object. So you're going to give resource access. A F5 team, you can define a resource only to have access only to the F5 devices, and you can give access only to their certificate group where the certificate belongs to the F5 team. So all this roles and resource will map to the user group, and the user group is tied to the user. And the user group, it can be a LDAP synchronized user group, and you can have your user defined as a member of the user group, and you can control through roles and resource. So we recommend to have three primary roles for any new onboarding that we do. One is the CLM admin, who have the complete access, who can perform end-to-end any action they want. And second one, the read-only admin role, where they can perform only the reporting, auditing kind of a stuff. And the third one is the CLM requester, who is restricted to perform any admin level access in the CLM. They are allowed to perform only the day-to-day certificate request or renew or revoke functionality as offline. So these are all the roles and resource that is defined. And with this, you can define the resource segregation and role separation. So once you have this defined, then the CLM tool will that you can apply the policy standards that you have, how to generate a CSR, and how who can enroll a wildcard certificate, how you can restrict the self-signed certificates, discovery controls, and you can have your expiry notifications, deploy certificates to your infrastructure, have your integration with all your external and internal CA, and how you can automate the renewal and all of that. So everything that you will be controlling with the one centralized console to enforce all your policies. So when it comes to PK policy enforcement through the CLM, these are all the controls that we need to have. The first and foremost is the access management control. How we can define an access management control. So we're going to show you, what are the possible way that you can do through AppViewX CLM, how we can enforce your access management control. Then follows how we can have a control over the visibility, the discovery of certificates. Then follow on by certificate ownership control, how we can control your certificates, how we can map the ownership and all of that. And then how we can control your enrollment process, like the key length, hash function, weaker key. You can avoid enrolling certificates with a weaker key and all of that through the policies. And the certificate provisioning controls, and then the audit and remediation control. So these are all the controls that we're going to discuss today. So resource control, I'm going to move on to the web UI to look into the options. So these are all the places that I'm going to show you in a bit. Just a moment. So before even we get into the rules, I wanted to discuss the certificate segregation. So when you complete the discovery and you have the visibility of all your certificates, the ground rule is the most priority one is the segregation of certificate. No matter it's just a certificate, if you take Active Directory, within Active Directory, you have a different application team or an infrastructure team or a network team and all of that. How you define the roles and the resource access and all of that, you're segregating by user groups, right? Likewise, when you discover all the certificates into AppUX inventory, when you bundle all of them into one single centralized location, you will have to segregate them by multiple different methods. And I'm going to give you few sample methods that customers can adopt. The model one, it's a most simplest one. If you have only public CA and internal CA and you have very less number of team, you don't have too many teams to handle and all of that, you can go ahead with just create a public certificate group, another group with an internal cert, and map all your public CA discovery job to be tied to this cert group, and the internal CA certs to this group. The second model, you can create the certificate group by the application team, like NetOps team, and they can have two different groups, one for maintaining internal cert and external cert. The reason why we are segregating this group, where you will have more granular level of applying the CA policies. You can apply the policies. For example, you have an internal certs group for NetApps, and you don't need an approval to be defined when they enroll a certificate. And within the policy, with the out-of-the-box features, where you can disable the approval for this certificate group and apply the policy where you don't need an approval. But if it is an external cert request, they will have to go through an approval logic. Likewise, you can define for every team. So in some scenarios, you might have a shared certificate. One certificate will be shared between infrastructure team or the application team, or maybe it's a front-end application, front-end device, or it's a back-end application server. Both will be using a same certificate, whereas the infrastructure team only have access to the infrastructure to provision the certificate, where application team does not have a provisioning privilege. Then you might have to put it in a shared certificate store where you can allow access to multiple different teams. This is model 2. And model 3, um, you can just define without segregating internal, external, just put all the internal, external cert specific to the NetOps team, Unix, and shared certificate. And the model 4 is the one that I would recommend. if you have a certificate, do not have a shared certificate for your multi-SAN certificate enrolled for your front-end devices and also for the back-end, right? When you enroll a certificate for a front-end load balancer, which is exposed to your external network, and if you have a backend application service running on an IaaS or Apache, Tomcat, and all of that, and you will have a FQDN address or the DNS address of your internal service that will get into your SAN value. So anyone who is accessing your external load balancer URL will be able to see your public content of your certificate. They will be able to see your backend server details, which where you're voluntarily exposing your internal DNS entries and internal information to your external source, right? So better to have a dedicated SAN certificate for your front end, for your load balancer, firewall, and all of that. And for backend, you need to have a dedicated certificate which holds only the internal informations. And in some scenarios, you can have, people will have external certificate enroll, which is cost involved, that will be used for your external and internal purpose. You don't need to have an internal application server which requires an external certificate. So you can define the difference between when you need an external cert, when you need an internal cert, so you can reduce the cost in terms of external certificate enrollments. And the fifth model, you can define a crown jewel application certificates. This more into the provisioning part. When it comes to provisioning, the crown jewel applications might require a change request in place. You might need a downtime, a scheduled downtime is required to provision a certificate. So in that scenario, you can have the approval enabled for the crown jewel application certs for non-crown jewel applications where you can go ahead and define the auto provisioning, auto renewal that can be enabled by default. All right. So let's get into the role access. So I'm going to go to, so we discussed about the certificate group segregation. Okay, that is the first primary requirement. Once you have the group segregation is defined, it follows on when you create any resource, you need a group. When you create any policy that you want to apply, that you need a group and all of that. So that's the reason we recommend to create the group segregation first. So I wanted to give you a small example of a client certificate download. For example, if you have a client certificate which has a SMIME key usage, or you have a encryption file system key usage is enabled, and you have enrolled a client certificate. If I, as a Kingsley, going to enroll a certificate, then I will be allowed to download my private key, where nobody else is allowed to download my private key. That is how it is defined within the product. So if you go to the client certificate, if I go to client certificate, where you will be able to, I will be able to download my client certificate because it is tied to my username. So I'm allowed to download my certificate with a private key, whereas I will not be able to download another user. Ajay is another user who enrolled certificate. I will not be able to download his private key because his certificate is, meaning if it is tied to SMIME or EFS, if I'm able to download his private key, I will be able to decrypt his emails or his encrypted files, right? All of that. So that is completely restricted within AppViewX. But in a scenario where you want to have a key recovery agent administrator, and you want in some scenarios where the SMIME certificate get corrupted and they submit a request to the PKA team to recover the key, to decrypt their old emails and all of that. So you have a role that you can define to allow an administrator group to have access to the private key of the users. They can download any user's certificate. This is one of the problem statement with a Microsoft CA, where you need to have a key recovery agent. Template has to be created. You need to create a blob and then to recover the key and need to give it back to the user. So when it comes to AppViewX, you can control this through a role. If you go to platform, so this is the role. This is not given by default even for the super administrator, where only the PKA team will be able to go ahead and create a new role and define this access for the list of administrators who can download any user's private key. This is applicable for the client certificate. Because when you look at client certificate and the server certificate, client certificates are tied to one-to-one mapping to the device or to the user, right? When it comes to server certificate, the server certificate is tied to a service where it can be allowed, the private key access can be allowed to a group of users, because the certificate is not tied to a user, or it is not tied to one specific device. It is tied to a service. So when it comes to a user group mapping, the user is mapped to a user group, and the user group is mapped to a resource and the roles. So when a user logs in to the portal using a single sign-on, he maps to a user group, where the user group is tied to the roles and resource. Roles, I told you, what are the actions that you can perform. When it comes to resource, if I show you one of the resource, so you can define, so this is one of the resource. If I go to access control, certificate, this is one of the certificate inventory group. So if I go to inventory group, so these are all the inventory groups, right? This is one of the group. So how many ever certificate that I have mapped to this specific group, I have access only to read, write access only to this specific group. So if a user logs in, and the user tied to the user group, and the user group tied to the resource, and the resource tied to the access level, read, write access to the certificate inventory group. So the user will be allowed to access only the certificate belongs to this specific group. They will not have access to any other group to perform any other actions. So with this, you can control the access level, resource and access level of the user, right? So let's move on to the discovery control. So what are the other ways that you can discover and segregate the certificate? So there is an option called discovery rule. If I go here, and if I wanted to open a test role, sorry. So these are all the rules that you can define. For example, Microsoft CA, and you wanted to discover certificate only if the certificate is issued through this template, then you can set it as is one off, and you can type this template name one below the other. So you can, when you apply this rule, when you perform a discovery certificate from a CA or from network discovery or from device-based discovery, this rule will apply on top of the discovery to pull the certificate only which is required. And another scenarios, this is one scenario. And other one, the most important one is the SAN. So you have a rule you can define based on your SAN entry. For example, if you have a DNS entry and the DNS entry, it starts with a prefix, you can do a regex and you can do a prefix value. For example, if NetOps team or a Wintel team, a Windows team who manages all the Windows servers, they have a prefix naming convention for all their DNS entries for the DNS value. You can define this and define this rule. So when you run a discovery on top of your network discovery or any device-based discovery, this rule will apply. And before mapping the certificate, it will apply this rule, and whichever is applicable, it will pull only that certificate. It does not pull the unwanted certificates. It will pull all the certificates required as per the rule and map them to the respective group. So when you define this rule, you have another option. If you go to discovery, let's say if I'm creating a managed device discovery. You have an option to apply the rule. And when you map the certificate managed or monitor, you can map the certificate to the certificate inventory group. So here I can go ahead and align my discovery job, post discovery, all the certificates will go and sit in this specific cert inventory group. So this is how the mapping works. So this way, with the rule, you can control your discovery. It's not that you don't need to pull all the expired certificate. Let's say you have an expired certificate in your CA, which might be expired 2 years back. And when you discover all those certificates, that will impact your license count as well. So you can have a more controlled discovery. The more accurate discovered certificate, you can pull more accurate report. The more cleaned inventory will have a better report, right? Otherwise, you will find a more unwanted certificate will show you a result which cannot be defined as non-compliant certificate to define your remediation actions. So it's better to have your cleaned inventory. In order to do that, you need to have a rule defined and perform a discovery accordingly. All right. One moment. All right. Then comes the CA policy. So when it comes to enrollment control, how you can control your enrollment, you can create your policy. And this policy is tied to a certificate inventory group. So I might be, keep saying groups. There are two groups. One is the user group. One is the certificate inventory group. The more I'm talking about the certificate inventory group. So the CA policy, you have a strict and suggestive. If you wanted to have the editable option, you can go for a suggestive method, or you can go for a strict method, right? Let's do suggestive. You wanted to enable approval, you can enable approval in the policy level, and you can enable the private key download access, and you can enable the certificate push and bind access for read-only users. So this is specifically for the infra team. The infra team might not need access to enroll a certificate, but they might need access to provision certificate to the end device. So you can apply this rule, apply this policy to any set of a group. This is the issuer root CA compliance. This one is the email is a mandatory. Whenever a certificate, user certificate, if you wanted to enroll a user certificate or a client certificate, you can mandate to have the email address as a mandatory field so that the email address will tie to the user to make sure the user is only allowed to download their certificate. And when it comes to CA, this is where you will define all the certificate practice policies. So you can define your key length or a hash function, and you can define the number of approved domains that you can include. You can keep creating, or you can have a comma separated domain list of whitelisted domain, and you can control the enrollment for the only allowed domains. If you wanted to block, you can do the same thing. And if you wanted to pre-fill all your CSR parameters, for example, organization is going to be same for all your enrollments, you can go ahead and do that. And for this is the predefined field, right? When it comes to strict and suggestive here, if you put it as suggestive, even though if you have pre-filled information in the CSR parameters, it will give an editable option for the end user. But if you put it as a strict policy, then it's not going to give an editable option where the end users, when they enroll a certificate, it will be pre-filled. It will become a non-editable field. So likewise, you can go ahead and define this CA policies and all of that. And when it comes to compliance control, as I told you, you need to have a clean inventory. In order to have a clean inventory, you need to have the defined policies in place, rules in place, and certificate segregation in place. And apart from that, you need to define the delete expired certificate option. You have the expired certificate. Make sure this is enabled so that you can set a date and how long you can keep your expired certificate within your inventory. For further auditing, maybe you can have it for 90 days to make sure the expired certificates are audited to backtrace whether the expired certificates are renewed or provisioned to the respective team and all of that. So you can control this through this expired certificate options. And when it comes to revocation policy, that also you can define an approval process in place if it is an external certificate. And if any employee who is leaving the company, then you might have to revoke their certificate. You don't need to keep their certificate active. So you can I would recommend to go ahead and revoke their certificates and all of that, right? So once you have this controls all in place, what is the next step? You have a server certificate, we have client certificate. It's not the only landscape that we need to enforce your policies, right? There are other places we have. So let me quickly go ahead and share my screen again. Hope you're able to see my screen. So you have your certificate lifecycle management. You have the policy in place. You already enforced the policy for all your certificate lifecycle. But how do you know you have enforced the policy in all your landscape? Do you have a policy enforced, the PK policy enforced on your IoT certificate enrollments? Or do you have the policy enforcement is applied onto your container environments? Do you have the policy enforced, right? Most of the scenarios, the DevOps team or the container environment, they wanted to have a faster enrollment, short-lived certificate, and all of that. If they want to have a ingress certificate, they will have to request. They cannot wait for an approval. They cannot rely on the time delay and all of that. They need a faster enrollment, and the frequency is high. So how do we enforce your PKA policy onto your container environment, right? And when it comes to your DNS, most of the scenarios, nobody cares about the DNS security. Within DNS, you have a DNS sec keys. You have a zone signing key. You have a key signing key. How do we rotate those keys, right? How do we enforce your policy, PKA policy onto those DNSSEC keys, and how we can do the domain validation and all of that, and that you can enforce the policy, and within your load balancers and firewall, your application control, how we can enforce. And the code signing certificate, we might think that code signing certificate is just enrollment of a certificate. What level of policy enforce we can do, right? We can just enroll a certificate. You already defined a CA policy. We might think that it is done. No, it is not, right? We need to know who is signing and who is maintaining the private key, because within the certificate practice statement is defined a control in place to secure your private key. So how to distribute the code signing certificate? Do we need to share the private key of the code signing certificate to the developers to sign the code or to sign a file? Or should we need to keep the private key secured within your HSM, and you need to perform a code signing operation through an API call or to an authentication mechanism without even sharing the private key? How we can enforce the policy, right? And most important thing, it's newest trend that there are non-human identities you have. There are many remote execution is happening, and there are more remote applications are developed where most of the secrets or API keys or service accounts or the backend MTLS certificate authentication, all of that is out of control. Nobody have visibility in that space. But how do we enforce your PKA policy to that? So AppViewX one as a one solution, as a one centralized console, which can help you enforce all your policy, PKA policy controls in all your certificate landscape. All right. So this is what we recommend to explore more. And within the product, you have an option to explore all of these options. I would recommend to go ahead and explore all of these options. So once you have a complete control of your PKA governance in all your landscape, then you need to look into not just the certificate. How can I make my PKA system more crypto agile? Meaning, let's say if Cap Forum today announced, if they announce that new PQC algorithm is enforced, and within 2030, you need all your applications to be compatible with your PQC algorithm. And if tomorrow someone able to break the RSA 2048, and you got an announcement tomorrow morning saying that RSA 2048 has been breached, and someone has already break the combination, we are able to get the private key of the 2048 key, and you will have to switch your PKA system immediately within few hours to get away from the breach. So how do you do that? Is your PKA system is agile enough? Ask the question yourself, right? Is your Microsoft CA is agile enough to do that? Is your current PKA system is agile enough to do that? Or do you need to look for a migration of Microsoft CA to your cloud-based PKA solution and all of that? So you need to think through this, and once you have this control, then the next goal is that you need to make your PKA system crypto agile, not just the certificate. All right, that is all I have for the session today.